day, everyone. So today, we're solving a kinematic equation. But first, let's know what is kinematic equation. Kinematic equation describe the motion of objects with constant acceleration relating 5k variables such as displacement, initial velocity, final velocity, acceleration, and time. So there are four primary equations in kinematic equation. The first equation is final velocity is equal to initial velocity plus acceleration times time. The second equation is change in position is equal to initial velocity plus final velocity over 2 times time. The third equation is change in position is equal to initial velocity times time plus 1.5 times acceleration times time squared. The last but not the least equation is final velocity squared is equal to initial velocity squared plus 2 times acceleration times change in position. So this equation can be applied to motion in one dimension or separately to each dimension for 2 or 3-dimensional motion. So we have a problem here. Our problem number is number 24, and our problem states that starting from rest, a car accelerates at 8 meters per second squared for 10 seconds. So let's find its velocity and the distance traveled. So we are dealing with a car that's accelerating, meaning its velocity is changing over time. We need to find two things. First, the car's final velocity after accelerating. Second is the total distance that the car travels during this acceleration. But before we solve this problem, let's drop down the given, or let's identify the givens. So our initial velocity is equal to 0 meters per second since it starts from rest. Our acceleration is 8 meters per second squared. Our time is 10 seconds. And ang ato gihanap is ang final velocity and change in position. So what equation formula are we going to use to find the final velocity? So we're going to use the first formula. The final velocity is equal to initial velocity plus acceleration times time. So the problem is given. The given and the formula is shown on the screen. So let's start solving. Before we solve, let's write down the formula. Our formula is final velocity is equal to initial velocity plus acceleration times time. So let's cancel the initial velocity since 0 maghihapon ang ija given. And the final formula that we're going to use to find the final velocity is equal to acceleration times time. Tag-derive na kibali dyan si Ja. And let's substitute. Ang ato acceleration is 8 meters per second squared. Ang ato time is 10 seconds. So, ato sabi times ini sila duha. 8 meters per second squared times 10 seconds is equal to 80 meters per second. Tag-cancel out ang isa ka seconds since J may ja kaparihas. So, our final velocity is 80 meters per second. So, since humana makita sa final velocity, let's proceed sa change in position to find the change in position. So, what equation are we going to use to find the displacement or change in position? We are going to use the third equation, which is the change in position is equal to initial velocity times time plus 1.5 times acceleration times time squared. So, our statement of problem, given, and formula is given on the screen. So, let's start solving. First, let's write down the formula that we're going to use to find the change in position. Our formula is change in position is equal to initial velocity times time plus 1.5 times acceleration times time squared. Let's cancel the initial velocity and the time since 0 maghihapon ang initial velocity. So, next step is ato i-derive inin formula. Since gi-cancel man ang initial velocity and time, so ang ato final formula is change in position is equal to 1.5 times acceleration times time squared. So let's substitute the given. Change in position is equal to 1.5 times acceleration, which is 8 meters per second squared. The time is 10 seconds squared. So let's multiply the 10 seconds by itself. So 10 times 10 is 100 seconds. So change in position is equal to 1.5 times 8 meters per second squared times 100 seconds. So 8 meters per second squared times 100 seconds is 800 meters. Gi-cancel out ang seconds since J may kaparehas na variable. So 1/2 of 800 meters is 400 meters, which is the change in position. So our answer is the car's final velocity after accelerating is 80 meters per second, and the total distance the car travels during the acceleration is 400 meters. Happy learning!